We got two factors. But let me tell you this. If the second factor is a block, I'm going to tell you what I mean by block. That we don't consider interaction. You know, we have two types of two-way ANOVA. We have two-way ANOVA with interaction. We have two-way ANOVA without interaction. The two-way ANOVA without interaction is what we call randomized complete block design. That is where we normally test, in addition to a factor, we test for the blocking factor. And which I'm actually going to give you an example. Let me first give you an example of the blocking factor. For instance, let's say you are into manufacturing of concrete cylinder. Concrete cylinder. You know, concrete cylinder, you are into manufacturing of concrete cylinder. Okay, this concrete cylinder is to be used for bridge support. Is to be used for bridge, for bridge support. Okay, this is what you are manufacturing. Okay, and you know what? You have different types of drying method. Drying, because you need to dry then. Maybe probably you are talking about A, B, C, D. Okay, it means drying is a factor. Okay, factor that has how many levels? 4 levels. Okay, for those of you online, if you cannot see the board, I'm trying to say you are actually manufacturing a concrete cylinder and for bridge support, and you have 4 possible drying method, A, B, C, D. Okay, you are looking for the best. You are looking for the drying method that will give you the best comprehensive strength. Okay, comprehensive strength. You are looking for the one that will give you the best comprehensive strength. But when you are producing this cylinder, you produce in batches. Okay, you produce in batches. Okay, there are different kind of batches. And you know what? Your production engineer observe that there is variation in quality from batch to batch. I'm going to say that again. Your production engineer observes that there is a variation in quality of this cylinder from batch to batch. If you want to look at the effect, of the levels of this factor, okay, on the strength, then you also need to look at the effect of the batches. The batches is block effect in this. And this is an example of a two-way ANOVA without interaction. You have one factor that have 4 levels, A, B, C, D, and you have a blocking factor. And the blocking factor is batches. If you have 4 batches, okay, like I said, the blocking factor is actually batches. When you have 4 batches, it means 1, 2, 3, 4. It means you also need to conduct, you're going to have 2 major hypotheses. The first set of hypotheses is going to be on the drying method. H0, there is no significant difference in the drying method. HA, alternative, there is significant difference in the drying method. There's going to be another set of hypotheses, and that is to test the blocking effects. What is the blocking here? Batches. the H naught is going to say there is no significant difference in batches. The alternative is going to say there is a significant difference in batches. So that is an example of a two-way ANOVA without interaction. So two-way ANOVA without interaction is what we call randomized complete block design. Okay, randomized complete block design. Your block here is the batches. Does that make sense to everyone? That is the batches. But there's another one where you can look at the effect of interaction. The one you can look, the two-way ANOVA with interaction is not a randomized complete block design. But a two-way ANOVA without interaction is a randomized complete block design. Now, I want to walk you through an example. Another example here, you are looking at the effect of gender, okay, and exercise on weight loss. The weight loss is quantitative variable, okay, because you are looking at the effect of gender. Gender is a factor. Exercise is another factor. The gender has levels. Exercise has levels. You know, whether you none is you don't do exercise at all, okay? And we have other form of exercise. I think we have 3 levels of exercise. We have none, light, and intense. Those are the 3 levels of exercise. But you got 2 levels of gender, right? Male and female. We want to look at the effects of gender and exercise on weight loss. In this one, this will involve two-way ANOVA with interaction. There will be interaction between exercise and gender. Okay, now you collected data set 10-10 on this interaction. And at the end of the day, I want to show you the ANOVA table. If you take a look at this ANOVA table now, like if you take a look at this, we're going to have 3 separate hypotheses. Number 1, hypothesis on gender. Number 2, hypothesis on exercise. Number 3, hypothesis on their interaction. This is an example of a two-way analysis of variance with interaction. Now we have one for the degree of freedom for gender because we got 2 levels of gender, male and female. We got 2 as the degree of freedom for exercise because we're considering 3 levels of exercise, none, light, and intense. I want you to look at the p-value associated with the gender. This p-value is less than 0.05. Okay, so which means there's a significant difference between the weight loss experienced by male and female. That's what it means. They have different experience in terms of weight loss because you are rejecting, because the gender is significant. The difference between them is significant. When you also look at the exercise, you know, you don't do exercise, you do light exercise, you do intense exercise. Of course, in terms of weight loss, there's a significant difference. That is what he's saying. And that is making sense because my belief is that doing exercise will make one to reduce weight. So you can see that now. The p-value is actually less than 0.05. What about their interaction? Interaction between gender and exercise, you remember the other time, there is possibility that the 2 predictors here, they depend, okay? And when the interaction is significant, that actually shows that they depend. One predictor depends, one level of one predictor depends on the level of the other predictor. But you know the difference between this, why we don't consider interaction in two-way and no, I mean RCBD that I mentioned before, because the assumption for the RCBD is that each level of the treatment factor is the same as each level of the blocking factor. But here it is not. It is not when the interaction is significant. What do you see now? Is 0.0141 p-value compared to 0.05, it means it is significant. Now, we also do testing assumptions. We test for assumptions in two-way analysis of variance as well. This is we can do the histogram of residua. We want to see whether it is normal or not. Okay, there are several ways to test for normality. You know, the other time I was using Shapiro-Wilkie test of normality. That's a standard way. Okay, we can use a QQ plot. We can use a histogram, all of that to investigate normality. Then you can, we also run a test of homogeneity of variance using Levine test. Take a look at that. Using Levine test, the p-value is 0.1177. which indicate we're going to fail to reject the null hypothesis, and that actually suggests the variances are the same. Now, we perform a Tukey test of multiple comparison. Why are we doing that? We're doing that because we've rejected the null hypothesis in each of the hypotheses. For gender, we rejected the null hypothesis. For exercise, we rejected the null hypothesis. For their interaction, we rejected the null hypothesis. And when we reject the null hypothesis, we need to conduct a further analysis, and that further analysis is multiple comparison test. Now, in the multiple comparison test for gender, of course, that is confirming again, there's a significant difference between the weight loss experienced by male and female, because the p-value here is less than 0.05. Okay, I'm talking about that guy there, right? Now, we also want to look at the exercise. The other time, you know, we are comparing 3 levels of exercise: no exercise at all, light exercise, and intense exercise. We realize that there's a significant difference between them, but the analysis of variance will not tell you where the difference lies. And that is the reason why to do that, we do multiple comparison tests, where we're actually going to have opportunity to compare them head to head. Now, take a look at the first one. We are comparing light exercise with intense exercise. You can see the p-value is 0.5, almost 0. That is significant, which means there's a difference between when you do light exercise and when you do intense exercise in terms of weight loss. Now, what about non and intense? Non and light, in fact, the difference exists in each and every one of them. And when you take a look at the the interval, you're actually going to see the interval is from negative to negative. That does not include 0. That is another confirmation that the significance exists in all these pairs of levels. Okay. Now, just like what I did the other time, what I'm trying to show now is for the interaction, the multiple comparison for interaction. Why are we doing this? Because we have rejected the non-hypothesis, we said the interaction exists. Now, if you look at the first one, we're comparing male intense with female intense. Is there any difference? If a male person is doing an intense exercise and a female person is doing an intense exercise, is there any significant difference between them in terms of weight loss? That is what we're investigating now. Okay. And take a look at this guy here. If you look at that guy, there is no 0 in between. Do you see any 0 in between? It means there's a significant difference between a male that is doing intense exercise and a female that is doing intense exercise in terms of their weight loss. The only one where the one that includes 0 is this guy here. A male person that is not doing any exercise at all, and a female person that is not doing any exercise at all. Okay, that is the last one. I'm talking about this guy here. Okay, we got a male person is not doing exercise at all, and a female person is not doing exercise at all. We want to compare their weight loss. Now their interval actually includes 0. When the interval includes 0, what does that mean? There is no significant difference between the weight loss. That makes sense to me because they don't do exercise. Okay. Now, if you want to report your results in an ANOVA, I think I put the way to report that. This is the way to report that. Okay, you report everything that we have talked about. The assumptions you've carried out, the decision you've taken. Okay, that is what I put there. Okay, so this is the multiple comparison that I talked about the other time. Now, this multiple comparison is for interaction. There's going to be a lot of interactions. The one that is not significant is male none and female none. And there's a lot male none and male intent. Sorry, male light and female light. Look at male light. When the male is doing light exercise and female is doing light exercise, there's no significant difference because it's a light. Look at that. The light is actually, so the when you do multiple comparison tests for different, it's going to compare different levels of interaction. That was going to, it's going to give you opportunity to be able to take decision between levels of interaction. Take a look at that. Where P value is less than 0.05 level of significance or 0.01 level of significance, of course, you're actually going to say different exists, but where it is greater, then the different does not exist. Now, I've talked about randomized complete block design the other time. And I remember I put this very example. You're going to love this example a lot. For instance, a particular restaurant is comparing 3 menu items. Okay. But they have 6 franchises. A factor is the menu items that have 3 levels, but you also need to investigate whether there's a significant difference in the franchises. The franchises is going to be a block. Okay, we got 6 blocks and 6 levels of blocks and 3 levels of factor. This is an example of a randomized complete block design. A two-way ANOVA without interaction is called randomized complete block design. Here, we don't need any interaction at all. I want to give you another example. For those of you who are in chemistry, biology, or who are in chemical science or biological science, that you conduct experiments all the time in a lab, if you are looking at the effect of something, maybe a factor, levels of factor, you want to see whether there's a significant difference between them. If you use more than one lab, you need to test for the effect of lab. Lab in that situation will serve as the block. Even if you are using the same lab, but you conduct the experiment every day, days become your block, your blocking effect. You need to test what is the effect of days. Don't only test for the effect of the factor alone, also test for the effect of days, because that could impact your results. So if we take a look at this, this is just a code my TA is going to run. We're going to run this with you, but at the end of the day, look at the summary table. This is a two-way ANOVA without interaction. Two-way ANOVA without interaction is called randomized complete block design. Now, I'm testing for the effect of items, 3 items but there are 6 franchises. And that is the reason why the degree of freedom for items is 2 and the block is 5. Because that will give you, if you don't do that, if you ignore the effect of blocking, because the way it is, when you bring all the franchises together, it's heterogeneous. You need to test for the 3 items in each franchise. Now, what is it telling us? The items are significantly different because of the p-value of 0.032 is less than the 0.05 level of significance. But what is it telling us about block? What is it telling us about block? The blocking effect is not significant. You know what that means? There is no significant difference in the franchises. That is what it's telling us now. End of story. Now, this is going to be the end of my lecture today, but I also want to appeal to those that have written to. I realize their submission is not visible. And I wrote to them, they need to resubmit in a different version, like a JPEG or PDF or Word document, so that their exam will be graded. If you are one of them, please respond by sending your submission to me on email. And lastly, if there's anyone in this class who is struggling, and maybe you've made an attempt to reach out to me by email, because I realize at times I don't get, when students send email to me, I don't know. You can give me a call. And whatever we discuss will be treated with the absolute degree of confidentiality. It is not too late to score A in this course. I appreciate if I acknowledge the fact that we find ourselves in the middle of a difficult situation. And that is why I've been kind of flexible, because I'm also a human being. I experience what other human beings are experiencing. And that is why I've been flexible. But I need you to reach out to me. Call my number, 763-501-6180. Introduce yourself to me, then we're going to talk.